Hey guys, I'm here to help with your 4.4 book assignment just in case I'm not at school tomorrow because of a sick kid at home. So I have some problems written out that I'm going to talk through. Just go ahead and feel free to go through the slides, whatever you need. If you need to stop and rewind, whatever, that's fine. Just do what you need to do to help yourself figure stuff out. First, before we do this, please make sure that you are working on 4.4, that assignment, not 4.3. If you're just following along on your orange sheet and didn't even pay attention, then you probably were doing the wrong pages. So that would have been one problem. So anyway, check 4.4. That's what we'll be going through. Okay, so for your first set of problems, which were numbers 3 and 7, the directions said to find these, let's see, where is it? The exact values of the 6 trigonometric functions of the angle theta. And in both of these problems, you were given an ordered pair, not an angle. Honestly, we don't care what the angle is. We just want to know what the 6 trig values are. If you look at any of the ordered pairs given, you should not recognize them from the unit circle because they're not on the unit circle. And in 3A, they actually, and in B, they actually give you a graph. So with the ordered pair, -3, -1 would be something down here. So our angle is something like that. And what we're going to do, and what we did in class on Friday, is that we are going to create a triangle to help us find this these values. So I'm going to go ahead and make my perpendicular line. I've got a -√3 as my x value and a -1 as my y. The triangle uses the reference angle theta prime, which is inside the triangle, but remember that's the same thing as using the actual angle measured from 0, this thing right there. But we get to use just the theta prime and the triangle itself. Now, unless you're using the trig or the unit circle, we're going to have to use SOHCAHTOA to help us find our trig values. So let's write out our SOHCAHTOA. Okay, and again, we're referencing our reference angle. That is the angle that we'll be working from. So the first thing I want to do is find the hypotenuse. So 1 squared, or -1 squared, plus -√3 squared equals our hypotenuse squared. So that's 1 plus 3 equals c squared. C squared is 4, which means c equals 2. And hopefully you do recognize this. Because of the sides, the short leg is half of the hypotenuse, the long leg is √3 times the short leg. This is a 30, 60, 90. But honestly, like I said before, it doesn't matter. I just want to find the trig values. Okay, so first, the sine of theta, and again, just looking at this triangle, opposite the theta is the -1, hypotenuse is 2. There's the sine. Cosine would be adjacent over hypotenuse, so adjacent's -√3 over 2, according to that reference angle. And then the tangent of theta is opposite over adjacent, or -1 over -√3, and we're going to rationalize and get √3 over 3. Okay, for the reciprocals, I'm just going to take all these values and flip them. So sine flips into cosecant of theta, which would be -2. Cosine flips into secant of theta, which would be -2 over √3, and again rationalize, get -2 √3 over 3. And then tangent, the reciprocal of that is cotangent. I could find the reciprocal of the solution, the √3 over 3, but instead look back a step. Look at this guy. Oops, where is it? This guy. Go ahead and flip that one and save yourself a step. Okay? So the cotangent is actually just the square root of 3. Okay, so for numbers 13 and 15, they both have the same type of problems. We're just trying to state the quadrant in which theta lies. Now, you can do this just by thinking about x's and y's and trying to locate it that way, or you can think back to that nice little chart we talked about on Friday, or the mnemonic on how to remember what's positive where. And if you remember, we put the A in the first quadrant. That represented all, so everything is positive in the first quadrant. Then S for the second quadrant, so that means sine is positive there. And because sine is positive, then its reciprocal cosecant is. T went to the third quadrant for tangent and then cotangent. And then C to the fourth quadrant for cosine and secant. Remember, we talked about the phrase, all students take calculus. Okay, so for number 13, you're given 2 facts. First off, that sine of theta is less than 0. So what I would do is just use process of elimination. If sine is less than 0, meaning that sine is negative, I know it can't be in the first quadrant because sine would be positive there, and it can't be in the second quadrant because sine would be positive there. Okay, and then the second fact, says that the cosine of theta is also less than 0. So I need cosine to be negative. I've already ruled out quadrants 1 and 2. The only thing I need to do is pick between my two possibilities that I have left. For cosine to be negative, it can't be in quadrant 4 because that's where cosine is positive. So my answer would be quadrant 3. That's the only quadrant in which both of these conditions fit. So that's what you're going to do for 13 and 15. Okay, now moving on to problems like number 19 and 23, in which again we're finding the 6 trig functions, but this time we're not given the ordered pair. What we're given is one of our trig values, so we have 1 down, 5 to go, and then we're also given what they're calling a constraint or a limitation on theta. And this is basically how we're going to figure out where theta is located. Now, if you recognize this tangent as part of your unit circle, you're in good shape. The problem is it's not a point on your unit circle, so we're going to have to go back to SOHCAHTOA to try and find all the other trig functions for theta. Okay, so now again, let's think about the quadrant. I know the tangent is given to us as something negative, so I'm going to be able to eliminate some quadrants from that. Tangent can't be negative in the first quadrant, so I know we're not in the first quadrant. And then if all students take calculus, we also can't be negative in the third quadrant. Okay, so I know my angle's either in the second or the fourth. And then we move to the sine. It tells us the sine of theta is also less than 0, so it's negative, which means it can't be in quadrant 2 because sine is positive there. So I know that this triangle or this angle is located in the fourth quadrant. Okay, so I'm going to go ahead and draw my triangle in the fourth quadrant. Remember, we're going to use the reference angle, so we always go right back to the x-axis because that's where our reference angle is located. And for this triangle, I've been given the tangent. So I know that the opposite side is negative 15, and the adjacent side is 8. So I'm going to go ahead and label my triangle with those values. Okay, if you recognize these numbers as part of a Pythagorean triple, you're in good shape. If you don't, then you're going to have to use the Pythagorean theorem to find that hypotenuse. I'm pretty sure 8 and 15 are Pythagorean triple with 17 as the hypotenuse. And you can check my math, but I'm pretty sure I'm right. Okay, so now we have a triangle, we have a reference angle. All we have to do now is find the other 5 trig functions. Okay, so let's go ahead and start with sine. Sine of theta would be opposite over hypotenuse, so negative 15 seventeenths. Then the cosine of theta would be adjacent over hypotenuse, so 8 over 17. And then of course we were given the tangent of theta as negative 15 over 8. And then we just use those to find our reciprocals. So the reciprocal of sine is cosecant, and that's negative 17 fifteenths. Reciprocal of cosine is secant, so I'll flip cosine and get 17 eighths. And then the reciprocal of tangent is cotangent, and that would be negative 8 fifteenths. And there's that. Okay, so for number 25, again, the directions say to find the 6 trig functions. This time they don't give you an ordered pair, they don't give you one of the 6. What they do is they give you a line that you're going to draw and then identify an angle in that given quadrant. So for number 25, they give us y equals negative x. So I'm going to go ahead and graph that line. So that's my line with a slope of negative 1 going through the origin. So it goes left 1, up 1, something like that. See how straight a line I can draw. Oh, not very straight. Oh well. Okay, so there's my line y equals negative x. And again, I'm only working in quadrant 2. So I'm just going to pick a random point in this quadrant that's on that line. And I just plotted a bunch, or 3, for my slope. So I can pick any of those 3 as long as they're in the correct quadrant. And I'm going to pick the biggest one just so I have it. Okay, so I know this point was located at negative 3 and positive 3. And then what I have is a right triangle. I've got a reference angle that I'm going to refer to, and I've got 2 sides of a triangle. Go ahead and use Pythagorean theorem, or hopefully recognize this triangle as a 45, 45, 90 to find your hypotenuse. So 3 root 2. And then we're just going through SOHCAHTOA again to find your sine, cosine, tangent, and then their reciprocals. Okay, next section. Numbers 37, 39, and 41 are all from the same section. It said find the reference angle theta prime for the special angle theta, and then sketch theta and theta prime in standard position. So for number 37, you're given an angle of 120 degrees. So I'm going to go ahead and sketch that first, and then we'll worry about where the reference angle is and how much it is. 120 degrees you should recognize is in your second quadrant. Probably not quite that angle, but you know what I mean. I'm going to go ahead and label it. So this angle right there is my 120 degrees. So that would be my theta. Okay? Your reference angle, remember, is always between the angle itself and the closest x-axis. It's positive, it's acute. That's the only angle it can be. So that is my, that is my theta prime. Okay? And then to figure out how big theta prime is, well, just remember, we're trying to get to 180 degrees. If we've already gone 120, then the only thing I have left over for theta prime would be a 60-degree angle. All right, so for 53 and 55, we finally get to the whole point of this section. Can we use what we know about reference angles, about locations of quadrants, to find sine, cosine, and tangent of any bigger angle without a calculator? Okay, so first I have 225 degrees. Think about where 225 is located. So we know 180 is our semicircle, and then 45 more degrees gets me the 225. So 225 is this right there. Okay. If you don't remember that point from your unit circle, that's okay, because what we're going to do is we're going to find the reference angle, we're going to take it back to the first quadrant, and those are the ordered pairs you just have to know. There's no way around it. Okay, my reference angle is the leftover guy between my angle and the x-axis, and that would be 45 degrees. So what we're going to do for 225 is base everything on the 445, or the 45 degree angle. Easier for me to say. Okay, so I'm going to think back to my 45. Okay, that is an ordered pair which you should know, and that's the square root of 2 over 2, square root of 2 over 2. Okay, so when I'm finding sine, cosine, and tangent of 225 degrees, really I can use the 45 degree ordered pair instead. The only thing I need to do is think about what's going to be positive and what's going to be negative. Now, so for the positive negatives, let's think about all students take calculus. We're working in the third quadrant. So the only thing that I know is going to be positive is the tangent. The sine and cosine will both be negative. And that should make sense based on that location. X would be negative, y would be negative. Okay? So for the sine of 45 degrees, that's our y value. And I know, again, it's going to be negative. So it's just negative square root 2 over 2. The cosine of 45 degrees, I would pull out the x value, so that's also negative square root 2 over 2 because it's negative in the third quadrant. And then the tangent of 45 degrees would be y over x. In this case, they're the same, so it's 1 as my ratio. Now, one thing I just noticed as I was writing these, I was writing sine of 45, cosine 45, tan of 45, but really what I was finding is the sine, cosine, and tangent of that 225, and I know that because I was putting in my negatives. So 45 degrees would all be positives, but 225 would involve some negatives. Okay, so you're going to do the same thing with number 55. Draw your picture, identify what your reference angle is, write the ordered pair for that angle in your first quadrant, and then think about positives and negatives. Hope this helped.